Yeah, so you are the host now. Yeah, Venkatesh. Please unmute Venkatesh. Your voice is not coming.
Yes, Adam, am I audible now?
Yeah, no audio. Yeah, yeah.
Okay, so shall we start?
Yeah, sir. We can start, Venkatesh.
Yes, sir.
Okay. Yeah, good evening, everyone. So today we will start the load flow analysis in the ETAP. In this, I will explain how to configure different study cases. And I think in the previous classes, someone has asked about how to create the scenario wizards, study wizards or not. So I will try to explain those things. Okay. For that, let me share my screen and we'll directly jump into the ETAP. Yes. So for that, first let me prepare a model, single line diagram. Then we start doing the load flow analysis with respect to that single line diagram. Okay. So here I am connecting. Let me use the feature of auto build. So and here you have the transformer here, and in this transformer you have one lump load connected and one more transformer. And from here, this is connected to some voltage. From here, let's connect one lamp load here. Okay. Right. Right. So let's suppose this is some 33 kV bus, for example, and here this is a transformer which is of, let's suppose it is of 33 kV, and this is of, let's suppose this is of 6.6 kV bus. Through this transformer, we are stepping down the voltage from 33 to 6.6 kV. And at the 6.6 kV end, we have the lump load, some lump load is connected. And there is one more transformer through which we are stepping down the voltage to further 0.415 kV or 415 volt. So let's suppose assume the transformer rating as, let's suppose 10 MVA here. Okay, and the lump load I'm considering is of near about 5 MVA, assuming it as a constant impedance load, sorry, constant power load. And here I am considering a transformer which is of, let's suppose, of rating 2.5 MVA, and the load that I am connecting here is also 2 MVA with the constant power load. Okay. So now what I'm doing is I'm replicating the same circuit here. So before that, what we have to do, let me configure some circuit breakers here as well. So for this, let me put one high voltage circuit breaker. And here also I'm putting one low voltage circuit breaker. And let's me replica the same circuit on the other side so that this will become like a 2 incomer and 1 bus coupler configuration. Right. So let's move the grid to this point and ungroup these things. So let's spend something like this, and I'm bringing the number to this point and moving this to here. To this point. Okay. Right. Now between these two buses, bus 5 and bus 8, what I'm doing is I'm creating a bus coupler. So there is a HV voltage circuit breaker. Take this and rotate this and connect it to this bus, and this circuit breaker to this bus. Similarly, we have the 2 incomer and 1 bus coupler configuration at the LV side also. So this bus 7 and bus 6. So there is an LV circuit breaker. Click this and just rotate this, connect to bus 6 and bus well. Okay. So, and the status of the breakers. So these breakers, this CB6, CB9, CB7 and CB8. That means all the normal incomers are closed. Normal incomers are closed and your bus couplers are open. So ensure that the circuit breaker CB6 that is closed. Similarly, the CB9 that is also closed. CB10 is open. Change the status to open here. Similarly, CB11, change the status of CB11 to open and ensure that the CB7 is also closed and CB8 is also closed. So this is one small typical example just to understand how to conduct the load flow scenarios and how to analyze the results and all. Okay. So this is a small utility means small industry which receives the power supply from the utility at 33 kV level, and we have two transformers, each of rating 10 MVA, and they are feeding to the different buses. So which is having the load of 5 MVA, and with that bus we are stepping down the voltage to 0.415 kV volt, in which we have the lump load of 2 MVA is connected, and the transformer ratings as I have indicated here. So this system is having 2 incomer and 1 bus coupler configuration. So now in the normal case, the incomers will be fed by the individual transformers. And if any transformer fails or if the circuit breaker opens, this bus coupler will close automatically and the entire load will be fed by this one incomer. Okay. I hope this assembly is clear, right? Now, so before starting any project, the first thing which we have to do is we have to ensure that the first details, like whenever you are doing a project, the first thing which you have to do is you have to go to that standards. That is the first thing which I already mentioned. So here you have to, before conducting any study or before creating a similar item, the first thing that we have to see is the project standards. Okay, we have already talked about it, whether IEC or ANSI, frequency, what is the unit system. And in addition to that, we need to give the project information. Okay, this is the project information. So here, let me put the project title as, let's suppose, practice 1, something like that. Practice 1. And let me put the location as, let's suppose, some ABCD is the location. And give the contract number as similarly, this is also some whatever it may be. And here you can give the engineer name and company name and all. So whatever the details that you can hear. Next, coming to the remarks here. So here we can write, of course, this remark is not really mandatory, but these are probably make sense when one engineer left the job and a new engineer who is coming and start doing the project. Okay. So whatever the information which you have given as a remark, you write it in brief. What is this project all about? What is the scope, and all this information will be helpful. It will basically helpful for the engineer, those who are coming late, to understand what this project talks about. Okay. Right. So that is okay. Next, go to the study module here. So this is the load flow. So go to the load flow here and then run the load flow. Okay. So here the details which we have missed it out. Go to the transformer and give the impedances, typical impedances I am selecting. Of course, as I told you, this impedance, ETA will follow the IEC 60076 part 5. As per that, it will take. Similarly, for T5 also, go to the impedance, and next is the transformer T3. Typical impedance, and here also, let us take the typical impedance. Okay, now just run the load flow here. Yes. So right now I am not worrying about how to improve the bus voltage profiles and all, but I am just seeing the load flow, how to conduct the load flow now. So how to do the load flow? So for that, what we have to do, you just go to the load flow toolbar and run there is an option called that is the run the load flow, right? Now, now let me go to the report here. So this is the report manager. Just check in the viewer portion. Yes. Right. So if you see here, all the results will be available. But if you see the information here, what I have given. Okay, what I have given in the project, like the project number, project name, practice one, location, ABCD, contract number. Sorry, someone is saying something. Okay, right. The file name. So all the details, whatever we have given, all the details, whatever we have given, that has been updated in this page. And this will be applicable in all the pages. If you go through that in all the pages, this you can see this project title, details, contract details and all, right? Right. So I hope this is clear. So what is the purpose of giving all these details? And if you give any remarks, that would also be replicated here. So this title bar will appear in all the pages of the ETAP report. Okay, now let me close this. Now probably we will look into how to open a study case. So whatever the modules, whether it is the load flow, short circuit, everything or all, so that it works in the philosophy of the study cases. Okay, so for that we have to create a study case. Now I have already created one study case and simply run this load flow here, right? But if we want to do any changes, so first what we have to do, we have to create a study case. So now this is the study case toolbar. So now let me open the study case here. Okay, so here you can decide in the report the voltage, whether the voltage has to be appear in the kV or the voltage has to appear in the voltage, that can be selected here. Similarly, the operating voltage, again same, the percentage, you have options. You can display that operating voltage in percentage, kV and voltages. Whether next is the power, so whether the power has to be displayed either in MVA or kVA, that can be selected here. Okay, Next, coming to this, this is the method, like the load flow solution method or the convergent solution method. Which method we are going to adopt to solve this load flow, whether it is an adaptive Newton-Raphson or a Newton-Raphson or a fast decouple. Probably in the earlier versions, we have the Gauss-seidel method as well. So if you ask the methods of solving the load flow, we used to say that Gauss-seidel, Newton-Raphson and fast decouple. But for the latest versions of ETAP, I think 19.5 and above, they have removed this Gauss-seidel option because other methods are now giving the better results than the Gauss-seidel. So they have removed this Gauss-seidel method itself from the load flow solution, right? Similarly, here there is an option we can select whether to apply the transformer phase shifts or not. That can be selected here. Next, coming to the update option here. So in which we can select to update the initial bus voltages and the transformer load tap changers, cable load amperes, inverter load amperes, everything can be updated as per the load flow results. That means whenever you are conducting the load flow or you are performing the load flow, so these things will be updated automatically in your signal line diagram. So I hope this is clear up to this.
So step 24, what option will come in the method, like the adaptive Newton-Raphson you have selected?
Sorry.
What option will come in ETAP? In ETAP 24, I'm asking the method you have selected, adaptive Newton-Raphson. So that similar option will be available over there also?
Yes. If you ask me,
so that option 24, we have to
but yes, yeah. So see, adaptive Newton-Raphson method is the our requirement is the load flow should converge, right? And that should match with the almost, it should give the accurate results. So we have the different load flow solution techniques available, but out of this, the adaptive Newton-Raphson method will give you the better convergence solution. So by default, this will be selected. But if you want to perform this with the another load flow convergence method, that you can select from here. But as of now, in ETAP, we have the 3 load flow convergence methods are available, which are quite popular.
Okay, thank you.
Okay, right. Next coming to here. So here, this is about the loading category. So here we have 2 options. One is the loading category and the load generation category. And what is the diversity factor? What are the adjustment needs to be done? That can be selected here. What are the alerts? So these are all specific to this particular study case. And here again in the study remarks, again, even you can write why we are studying this particular case, on what conditions we are doing this this study case. So what are the conditions that we are considering for this case? So everything can be you can write in the study remarks. Okay. So let me just write that the case is done for, let's suppose it is for 100% grid voltage. Okay, 100% grid voltage, right? So I'm just writing a study remark. The case is done with 100% grid voltage. It is just only a remark. So if somebody comes and reads this in future, so they can easily realize this case is done with the 100% of the grid voltage. Okay. Yes. So let's suppose I want to right. So I think this is clear. So now we can probably have a few more cases. Let us say, for example, if I want to run this case, maybe with say 90, with say example 95% grid voltage as well as 105% grid voltage, which I mean I can perform this bus by simply selecting this category to the design category. We can change this. Okay. Now, if you see the generation category here, so it is like different options, design, normal, shutdown. But I really do not know by means of looking at for design, what is the voltage, for normal, what is the voltage, and for shutdown, what is the voltage. So to do this, so there is another option in ETAP that is called project. Under the project, so you have the option of settings, and here there is an option called loading and generation category. So if you see here, so this is the generation category. So whatever the drop down that you are seeing in the load flow study case, so that is exactly the same. The design, normal, shutdown, emergency, standby, everything and all. So here you can probably change this. Like for example, in the design, I am changing it to, let's suppose it's 100% grid voltage. Okay. And this is, let's suppose 95% grid voltage. And let's suppose this is 105% grid voltage. And you just delete the remaining. Okay. Right. So now if you go to the inside the grid now, go to the rating here. So you can see here, this value has been changed. You might have noticed it is as 100% grid voltage, 95% is grid voltage, 105% voltage. So please remember, so there is no relation between what is the value which you are entering here and what you have given in the percentage. So this is just only an indication to understand easily about what is the case which you are considering, right? So this is just for understanding purpose, that too for doing this load flow. Under the load flow, you have the generation category just to understand for which case or which condition that you are considering for that load flow case, just to understand that purpose only. We have changed the description. Okay. But there is nothing like what are the voltages that you have given here, they will be considered in this case. So now what I have done, I have just created a first case. Okay, with a 100% grid voltage. So here, why I am telling you 100% grid voltage, that is the generation category that I have selected it as 100% grid voltage. Okay, right. So run the load flow here, and here the grid voltage is 100%. Okay. So I'm done with the first case, and I want to run, say, for example, two more cases. So what I'm doing is I'm creating, let me rename this to first 100% grid voltage, 100% grid voltage. Okay. So once you do that, so you can see here the study case name is 100% grid voltage. Okay. Now let me create two more cases. For to create a case, you have the option, either you can select the new, or you have the option to copy this. So if you click on the copy, so here the 100% is grid voltage. So I am creating one more case, that is 95% of the grid voltage. Okay. And again, I am creating one more thing, that is 105% of the grid voltage. Okay, click OK here. So now if you see here, I have three cases, 95% grid voltage, 100% grid voltage, and 105% grid voltage. Now first let's run this 95% grid voltage. Run this. If you observe here, we have run the case study for the 95% grid voltage, but still if you observe here, the grid voltage is 100%. So if I suppose if I run the 100% grid voltage, again the grid voltage is 100%. 105% grid voltage, which I am running again the grid voltage is 100%, which means only by making the naming will not really make any sense. You need to be really carefully alert what is the configuration which you have done so far. Okay. So for this case, this is your, let's suppose go to the 95% grid voltage here. Okay. So when you are doing the 95% grid voltage, so first the thing we have to select is in the generation category, you have to select the generation category as 95% grid voltage. Okay. And in the remark, you can change this as 95% grid voltage. Okay. Similarly, go to the 105% grid voltage, edit the steady case, go to the loading option here, and here you change this to 105% grid voltage, and in the remarks, you just leave it as 105% grid voltage. Of course, these remarks will not going to change any results. Okay, where you need to change is you have to change the generations category of the study case. Okay, right. Because why earlier we are getting 100% is because even though we are running different study cases, but in every case, the generation category, what we have selected is of 100%. So that is the reason why whether you run 100, 105, 95%, the grid voltage remains 100%. Okay. Click OK. Now, the next important thing that you need to look into is in this space. So here we have to edit the voltages. Like for 100% grid voltage, the grid voltage is 100%. For 95% grid voltage, you change it to 95%, and for 105%, you change it to 105%. Okay. Now if you run the 105% grid voltage study case here, now you see here, this becomes 105. Okay. Now if it becomes 95% grid voltage, so the bus voltage is 95. Similarly, for 100% grid voltage, the bus voltage is 100%. Okay. I hope this is clear. So if you want to flow at a different cases like 100% grid voltage, 95%, 105% grid voltage, or whatever the different voltages, what you need to. First, you have to create the generation categories. Okay. For all the voltages which you want to run. Okay. From this project settings, and under the project settings, you have the option of loading generation and SOC strategies. So in this, you can create whatever the voltages which you want to run. Okay. Then you need to give the suitable name for the generation categories that has to be done using this project settings, loading and generation categories. And under this, you have the option of the generations. Okay. So once you have done this, probably you have to go to the study case, and here you have two options. Every time you have to go and change this generation category here, and you can run, or you can create different cases, different load flow study cases for a different scenarios which you want to run. Okay. So till now what I have done, I have created 3 different cases. All the 3 different cases are appearing here. And even for tomorrow, if somebody comes and open this file, so they can easily understand this case is done with 95% grid voltage. This case is done with 100% grid voltage. This case is done with 105% grid voltage. So all these things, they will be able to easily understand and hope it makes sense, right? And if you run the load flow, and if you go through any report also, just open it. And if you see here, so here you are seeing, you are able to see. So this study case is for 105% grid voltage. So whatever the remarks that you have mentioned, so that will appear here. Okay. Similarly, for your 95% grid voltage, everything. So this can be reflected in every page. Up to this means this is the title bar and this remarks toolbar will be appear in all the pages of the ETAP report. So just by seeing the report itself, you could be able to know like for what are the conditions that you are considered for this particular study case. Right. So if I want to run with 100% grid voltage, what I have to do, I have to just select to this 100% grid voltage and I have to just run this. If I want 95% grid voltage, you just select this 95% grid voltage, so you just select it and run it like this. So in future, after hundreds of equipments are added, every time you cannot really go and change each and every individual parameter, right? So whatever the possible configurations which you want to operate, you can just simply select what is the scenario which you want to run, and in a single click, you will get the results, right?
So what is that below line, below PQ, the toolbar?
Sorry,
The case study running your load flow below that, what is the circle, red and
this is auto runoff. Like if you are changing any parameter, like see, every time I am doing this manually, right? Suppose if I change some parameter to, let's for example, change this rating to 20 MVA. Okay. And the load flow results will not be updated. So what you have to do, again, you have to go to this option, run the load flow option here, and you have to run this. Okay. So instead of that, if you make this option on, so whenever you do the changes, so it will do it automatically. Like if I change it to some 15 MA, for example, something like that. So the results will be updated automatically. Okay. So here it is 670.9. Now if I change it to, let's suppose 10 MVA, back to 10 MVA. So now here the results will update automatically. Okay. Clear?
yeah, clear.
Right.
Hello, sir.
Yes.
Sir, in this SLD, you have mentioned one grid. Suppose if same SLD has a different source like a backup generator or PV, in that case, the generation should be within the same voltages or it may vary, and how we define?
Yeah, see, that means the thing is you need to look into this. Means this is one scenario that I am explaining. Suppose if you have some co-generation plant which is connected to this bus, for example. This is the generator here. Suppose if you have the configuration something like this, right? So here first you have to check means with this generator, what are the different scenarios? First you need to analyze on your own. One option is the entire system will be fed by this utility, and the second option is entire utility is being fed by the generator. So you have to create the different scenarios. Like in that generation category, again the same. Means with this generator, whether you are able to meet this complete load requirement with this single generator. So in that case, again, you have to perform this cases 100%, and that 195% is completely depending upon your generator parameters. What is the maximum and minimum voltage variations that is allowed with the generator data sheet? So according to that, you have to create the different cases. Okay.
Okay, thank you.
Yeah, someone is asking something.
Sir, if I want to run the generator on the base load and with in sync with the grid, how we can do, sir?
Generation with the base load. So here
Yeah,
it's also the same.
yeah. If when, for example, some of our sites, the grid is not stable. So what we do is we also run some generators in parallel. So we sync the generators with the grid mode, PQ mode.
Okay. So here you have to give, means if you want to control your active and reactive power, means active power, so you can select it here. Or if you select this in the voltage control mode, if you select in the MVR control mode, this one, so here you have to give your megawatt and MVR. Let's suppose the entire load consumption of the system is, for example, let me run this. This is near about 272.5, and if I go to this kilowatt, it is 12.021 megawatt, right? Now, suppose if I want to run this generator for the base load operation of, let's suppose, some 6 megawatt, for example. Here the generation capacity is 10 megawatt. Let's suppose I'm operating it a base load of, let's suppose 5 megawatt, and MVR is also, let's suppose some 5 MVR, whatever it is, just for example. And I'm selecting OK here. So select the 100% grid voltage. And run this here. So now your generator is operating at the base load of 5 megawatt, and remaining requirement will be fed by the source, or that is the grid. So because this we have assumed it as a swing source.
Oh,
Okay.
thank you, sir.
Right. So let me go back and delete this one. Okay. Yes. So I hope this is clear.
Sir, in steady case, what is the contribution of the adjustment?
You are talking about this one, right?
Yes, sir.
So this is like the purpose of conducting this adjustment is, say, if you have a transformer here, if you go to the impedance here, the transformer impedance is 8.35%. Okay, but it is not possible to exactly manufacture the transformer with an impedance of 8.35. There will be some tolerance, right? IEC tolerance, plus or minus IEC tolerance. Suppose if you say my transformer impedance is 8%. So manufacturer, it is not possible to exactly manufacture the transformer to the impedance of 8%. So there may be some slight tolerance which should be within the IEC tolerance limits. Let's suppose for this 8.35 transformer, I am giving a jet tolerance of, let's suppose, some 7.5%. Okay. So the purpose of the load flow is I have to identify what is the loading of the transformer and what is the voltage drop of the transformer, right? So when I am selecting this adjustments here, so what it will do is for the load flow, it will take the positive tolerance. That means if it is a 8.35, but instead of taking the 8.35, what the ETAP will do, ETAP will take 8.35 plus or minus 7.5%, plus 7.5% tolerance it will take. That means your impedance will be increased.
Sir, one doubt.
Yes.
Sir, generally we will take negative tolerance, right? Because if we are taking the negative tolerance, then there is a chance for maximum fault
Wait.
current or worse
Yeah.
condition.
Yeah, let me explain here. I have not completed yet. Okay. Suppose simple way, take this as 8%, 8%, and take this 10%. Okay. So as I told you, for ETAP, the purpose of conducting the load flow is to find out the loading of the transformer and to find out the voltage drop, correct? So if your Z is more, that means voltage drop that is equal to V is nothing but I into Z. So instead of load flow, for the load flow, you have to take the positive tolerance. Why? Because your impedance will be more, your voltage drop will be more, because you are doing for the worst,
Okay.
right?
Yes,
So
yes,
that means
yes.
for the short circuit, you have to go for the negative tolerance, because when the impedance is less, your short circuit current will be more, right? So
Yes, sir, exactly.
when you select the adjustment here, so ETA will automatically pick up the tolerance as per the specified values from here. Okay. So for load flow, it will automatically take the positive tolerance. For the short circuit studies, it will automatically take the negative tolerance. Yeah, I hope this is clear.
Yes, sir.
Right. Fine. So let me to make the results equal. So I'm just taking the typical impedance, and now the load flow is updated. So because this option is auto run option is enabled. So every time I need to go here and run the load flow just by changing the values. So it will refresh it automatically once you change the values. Okay. I hope this is clear up to this. Now here one thing which I want to see, let's suppose this is 95% grid voltage. I run the load flow, and going to the report manager. And if I see here, so this is 95% of the grid voltage. Now again, if I change this to 100% grid voltage, run the load flow and go to this. And if I see here, that is 100% grid voltage. So here there is a problem. That means every time when I am running the load flow, I'm writing the report with the different grid voltages, the old report is not there. Like previously I have run it for 95% grid voltage. But now if you go through this, I am able to get only the 100% grid voltage report, but not the earlier what I run is the 95% grid voltage is not there. Okay, now we have only 100% grid voltage, and previous report what you have run with the 95% grid voltage is no longer available with you. So the purpose of running the multiple cases is to simplify, compare one case with the another case and say what is our observation in a different case. Is it available here? With this option, that is no. So if you want to compare multiple cases, what you really need to do is here. So here, if you see, it is basically look like an untitled. That means the report what we generated will come without any name as untitled. Okay. So here, when you are running this report, so that report, like if I run the report and go to the report manager, so whatever the report that you are running, that is coming with a title of untitled. Okay, if you see here, this is untitled. And every time when you change the study case and run the report, so this untitled report will get updated. Okay, so if you want to create different reports, so for that, what you have to do, instead of this untitled, you have to change it to prompt. So if you change that to prompt, when I am running the load flow here, let's suppose I am running the load flow, it will ask you what is the name which I need to give. So I am running the load flow for 95% grid voltage, and here I can change it to 95% grid voltage. Okay. Similarly, now change it to 100% grid voltage and run. If I run this, sorry, I have not changed this one. So again, go to the prompt here. Okay, here you should be careful every time. So 95% is grid voltage. So if I run this 95% is grid voltage, results will be updated in this report. Now, if I change it to 100% is grid voltage and again change this to prompt, if you run this, so it will be 100% is grid voltage. Okay. Similarly, for 105% is grid voltage, give this to prompt, run this, so it will be 105% is grid voltage. Okay, right. Now, if you see here, so here we have the reports available. You can see here, this is 100% grid voltage. There is a report and which is available in that. Okay, so now if you look at here, all the three reports are available with us, 95%, 100%, and 105%. All the three reports are available. Of course, untitled, previously we have generated a report that is also available. Of course, that is not really making any sense in this, but we have 95%, 100 and 105%. These three reports are available, right? Now the next question is it possible for me to compare the results of all these three cases? Like, is it possible for me to compare the results of 95% grid voltage, 100% and 105% grid voltage? All the three results can be able to compare at one place. That can be done. So for that, there is an option called the load flow analyzer. So go to the load flow analyzer here. So here we have the option 95% grid voltage, 100% grid voltage, 105% grid voltage. If you don't want to display this untitled, so you can probably delete this. Okay. So where do we need to delete this? Where these files will be located? So for that, you have to go to the ETAP folder here, ETAP 21.1, and in this, what is the name of the project? Project is okay. So this one, right? So this is the project which you are working upon. So if you see here, this is 95% grid voltage load flow case, 100%, 105% load flow cases. Okay. There is an untitled call, untitled load flow. So you can select and you can simply delete that one. Okay. Now, if you go and see here, so here you will not get that untitled. Okay. So this file will be saved in the ETAP folder, like ETAP21, where you have installed the software. Probably if you install the software with some other version of the software, go inside that software version and look at the file name. As the file name is .oti file. Okay, this is the ETAP training _1. So go to that folder and here you can see there is a file called, earlier we have the file called the untitled.lfs1s, right? That basically decides what the information which appears here. So untitled was also there and I have deleted that. Okay. And if you go back to this place, so probably you will not, means you will not find that untitled here again because you have deleted it from there. Okay. Like if you have say example 10 different cases, which you have read, if you want to select, see only 3 or 4 cases, that is also much possible. Okay. So for that, what we have to do, we have to go to the load flow analyzer. And here you have the different 3 study cases, what I have selected here. Okay. So here what I'm doing is I'm comparing these 3 study case results, 95%, 100% grid voltage, 105% grid voltage. So all the results I am comparing it. Okay. Right. Now go to the bus results here. So this is basically this is the general information. Okay. You have a bus voltage of here, if you see, it will get in this. Yeah. Here you have the bus voltage of 95 and here you have the 100 and here you have 105% voltage. What's the percentage voltage? And for the over voltage, about what percentage it has to appear in the red or what percentage it has to appear in pink, that you can decide from here, which means what is the marginal alert and for that what will be the color, what is the critical alert and what will be the color that can be selected from here. Okay. And same colors that you are displaying it here. Similarly, you can give the color for your under voltage also. What is the critical alert? Below which voltage this is critical and below this voltage it is just a marginal alert. And if you don't want to see, you can uncheck all these things. Okay. Right. So the choice is absolutely yours. Under voltage or over voltage, if you want to see, we can see balance will not be there. Right. Everything is now become white. So here it really does not make any big sense, but it makes a big sense when you export this to a Excel sheet. So you need to really struggle to give the report to the customer, typing all the values manually, but here nothing is needed. Just what you have to do, you have to, what are the things that you want to select? You just select this and click this and Excel, support the Excel. So now here you can see everything you will get into. Okay. Yes, I hope that is clear. Sorry. So for that, what you have to do, you have to just simply export that report and this takes to an Excel sheet and load for consolidated results. That's an Excel name which I want to give and Excel is ready. Excel is also saved in the same path of the consolidated results that is inside the ETAP folder. So here you can see this is the Excel sheet with the project title. And you can see here what is your study case IDs. So 95% is what is your generation category, what is your loading categories, what is your diversity factor, how many buses, how many branches, how many generators, how many power grids, how many loads, what's the load, active and reactive power, real and reactive power, what's the mismatch. So that's about the gender. When you take about the bus here, so here it will show you what type of bus it is, whether it's means what is the voltage profile of the bus, how much voltage it will be. So all these things can be displayed here. Branch, you can see what is the power flow that you can see here. Load, here we have connected the load. So here we can see the load information. And the source. So this is about the source information because here we are having only single source, that is the utility. So here you are able to find only the single source. Okay. Right. Now coming back to this. So that is about the bus results. So in the branch results, suppose if you want to select, like you have the option to select. If you want to means some more other information in the branch, that you can see, like here, if you see here, the ampere flow is appearing. If you go to the result here in the branch, you are able to see the ampere flow. Okay. Because in the branch flow, here we have selected the ampere flow. Instead of amperes, if you have selected, let's suppose kilowatt flow or power factor, percentage of the power factor, or percentage of the voltage drop, or percentage of the losses. So, and again, if you are exporting it, then that particular corresponding will appear. Okay. So if you see this, you just go this, and I think we have to give it the different name. Yeah. Now, if you go and branch here, so here you will see the trading devices. So depending upon the options that you have selected here, so you will get the results in the Excel. Okay. So you can have maybe a few more options as well, like here you have the actual values, and probably you can like option to, you can skip same if the results are almost within this range, 0.01% is the range, then automatically that will not showcase the results, right? That's possible option is also there. If same, we say like the mismatch is suppose less than the 0.01%, then that percentage you can select it from here, or you can show the difference with respect to the references. Like we have selected a reference, okay, 95% grid voltage only, and when there is a change in the value with respect to this base case, that also will highlight. Okay. Similarly, you can look at for a means the loads sources also. You can have the different options to select. Okay. So now advantage of this load flow analyzer is I can just simply export this, and I can probably easily put it in the report to the end user. Say example, if I have a 2-bus system like this, it might not really making a big sense. But if you have a system consisting of some 200 and 300 buses, so if you have 2 or 3 possible case scenarios which you need to run the load flow, so all the cases could be run in a single click, and you will get the results in a consolidated Excel sheet. Okay. So we have seen a few options. Any questions or clarifications as of now?
Sir, can we the all load flow results will run at a time, or we have to go for one by one?
No, that can also be done. I will come to that. Okay. Just wait for some time. I will also explain that. Yes. Yeah. Anything else?
Sir, on right side there is a PQ tool, blue color. Can you please
Which one?
right side tools below? Percentage. Yes, that one.
That is not for this. This is for the UPS systems. Yeah.
Okay. Okay.
Okay. Yeah. Yes. Anything else?
Can it be displayed in the PDF also, or we have to go in the Excel only?
That can be done. But no. This one is, it will
Done in
automatically a load flow analyzer. It will export in that Excel only.
Okay.
From Excel, you can convert it to PDF, right? Right. Yeah, I hope this is clear. This portion of this one means how to
Yes, sir.
do this analyzer reports and all. Right. So I guess like we have discussed about this generation category, that 100%, 105%. Okay, now we have seen how to do the and how to analyze the results in a single shot, like with what to say, the load flow analyzer, how to analyze the results that we have seen. Okay, now we'll do one more thing with the loading category, right? Write the generation category like 100%, 105 and 95%. We have the loading category also. Okay, so let's do some experiment on the loading category. So then we will come this and we will discuss what is this loading category talks about. Okay, so for that, let's do one simple thing. So we will create different cases like minimum load, maximum load, and average load. Okay. So for this load category will be applicable only to this nodes, right? Now again, if you see here, the loading category, you have different options, design, normal, break, winter, something like that. So what we will do is, like the generation category, we will change it to loading. We will change it to as per our requirement, like maximum load, minimum load, and the average load. So for that, what we have to do, again, we have to go to the project here, go to the settings, loading and generation categories here, and in the AC load, because this is our AC system, so it will be under AC loads. Okay. So here, basically, three cases which we want to do. One is maximum load, Next is the average load, or you can say it as a normal load. And it is the minimum load, and delete the remaining. Okay, fine. So similarly, I have created three different load categories. One is maximum load, normal load, and minimum load. Right? Right. I think this is clear. Now, here the maximum load is, let's suppose it is 100%. The normal load is, let's suppose it's 70%, and the minimum load it is of 50%. Okay. If you give this, automatically those values will be updated here. Okay. Now, so here, one thing which we want to see is, now we have created different generation categories and different loading categories. Okay. So let's take me one Excel here, and probably what are the different possible combinations that will appear with these cases. So if you check this, so we have three categories. One is the generation category, and here you have the loading category and probably the case name. Okay. So generation category, here we have 95%, 5% grid voltage, and 100% grid voltage, and 105% grid voltage. Okay. Why I have given the gap is because in the loading you have maximum load, minimum load, and average load, right? So total 9 cases means I have 3 possible generation combinations and 3 possible loading combinations, right? So if I put a permutations and combinations, I will get total 9 combinations, right? That is, for 95% grid voltage, I have maximum load, normal or average load, and minimum load. Similarly, for 100% grid voltage, again the same. I have the maximum, normal, and minimum. For 105% also, again the same, the maximum and normal and minimum. So all these 9 possible cases are practically possible. Okay. Now, if you keep adding such kind of cases, like the maximum grid voltage, which is of 105% grid voltage, or the minimum grid voltage, that is 95% grid voltage, nominal, which is of 100% grid voltage, and you have the maximum, normal, and minimum load. So you need total at the base level, you need 9 different cases. Now let me put a question. Do we need to run all the 9 cases, or shall we eliminate some cases? Any answer that I can expect? Is it like, for finding out the worst possible case scenario, is it required for me to conduct all these 9 cases, or can we eliminate some cases?
We can eliminate, sir. For
Yes.
95%, we can eliminate the maximum load.
I hope that's not correct. Yes, we need to. Yeah, we can eliminate some cases. Logically, you can run all the 9 cases, nothing wrong with that. But what we need to ask ourselves is it really needed? Like, is it adding any value? So logically, only one or two cases gives the worst or the extreme cases, right? And if all other
Yes, yes.
cases, example, if I am putting it like this way, then you will get a clarity. If we have one extreme and if we have one another extreme, which we find out, and if the remaining all the cases fall in between these two extremes, then we need to find out only the two extremes and we need to just eliminate all the remaining cases. So what we need to do is we need to just look at three cases at least. And one case which you cannot neglect is this case, 95% is grid voltage and maximum load.
Maximum load. Yes.
Yes. Why?
Because this will give you the worst voltage profile. Correct?
Yes.
That is, grid voltage is minimum possible with the maximum possible load. That gives the under voltage scenario for my system. So that's giving under voltage or minimum possible voltage for my entire grid. And that's giving a maximum load. Okay, and that will obviously that will be the maximum current because the voltage is less. So still I am trying to draw more power. So I is inversely proportional to voltage because the loads, whatever I consider, they are the constant power loads. So your power will be constant. That means if the voltage gets reduced, so automatically the current will increase. So this will give you the maximum loading. On other side, this 105% grid voltage and minimum load.
No load conditions. Yeah.
Can someone mute the mic, please? Yeah. 105% grid voltage and minimum voltage. So that is this gives the maximum voltage possible with the system. That's going to give the other extreme. Okay. So, and next there is one case that is 100% grid voltage with these three conditions. If you do, there's no issue in that. So 100% grid voltage, maximum load, 100% grid voltage, normal load, 100% grid voltage, minimum load. Okay. So if you just perform these 5 cases, that's more than enough. And if you want to run the other cases, yes, that you can perform and you can validate that also. But logically, what we are running is these two are the extreme cases. Okay. So if you if you were running these two cases, that is going to cover both the extremes. One is giving the minimum possible voltage and the maximum loading, and the other one gives the maximum possible voltage and minimum loading. So no other case which is going beyond this extreme results, right? So you can really neglect the remaining all. And if you have decided to do, or if the customer is asking you to do, but that's not really going to make any sense. So by these two cases, since it is a maximum voltage and a minimum loading, this gives like whenever there is a voltage rise, if you want to limit the voltage rise, then you may need some shunt reactor. That's one thing which you need to really look at that. And when you say minimum loading, how effectively these equipments are utilized, whether to switch off some transmission lines, you have multiple lines but carrying less power, so losses are high. So switch off some transmission lines and it helps to identify that particular case. When you are looking at the minimum possible voltage with the maximum possible load, you may need some shunt capacitors for a power factor correction or to boost the voltage or to support the voltage. So logically, if you have a scenario like this, running only these two is enough. But typically the end user may ask what's the normal condition also. So one case that you can select it as 100% grid voltage normal load. Okay, this is the natural case. Then this one is extreme and another one is another extreme. But in an extreme, in a year or in a day, like you have 365 days, 24/7. That means total is 24/7 and total it will be 8760 hours. So this extreme will be there maybe for a few minutes in an operation. So predominantly this operating point is going to be in between. So if the customer asks, we have to perform all the 9 cases. If the customer doesn't ask anything, probably performing this case 1 and case 9 will be sufficient. That's enough. And if you want, you can create all the 9 cases. Okay. So like for 95%, you can create these three scenarios. 95% grid voltage maximum, normal and minimum load. 100% grid voltage with maximum, normal and minimum, and 105% grid voltage with the maximum, normal and minimum. Okay. Right. Now what I'm doing is I'm going back to the ETAP and I try to create these cases. Okay. So for that, first what I'm doing is I'm deleting these cases. Right. Now if you see here, so there is nothing there. Here you have no results without. So now here in the study case, what we will do is, let's suppose for 95% grid voltage, let's take that case. 95% grid voltage. So I am making it more clear. This is with minimum load. Minimum. Sorry.
Sir, can you open the Excel?
Yes.
Is with maximum load.
Okay. So here I'm trying to create 9 scenarios and I will explain you. Someone has asked me, right, how to run all the cases.
Okay.
Let's explain that. Yeah. This is 95% grid voltage and the minimum load. So you can write this minimum load. And in this category here, you have to select the minimum load. Okay. Create OK. And go to this again. Select this 95% grid voltage minimum. And this is, let's suppose, normal load. And in the loading category, change it to normal and select OK. No, here. Okay, let me copy this one. This is 95% grid voltage minimum load. Which one we have missed it? Minimum load. Click OK and go to the loading here. Select the minimum loading. So this is 95% grid voltage minimal load. Okay. Now there is another case that is 95% grid voltage normal load. Change this to normal load. Okay. Next, copy this and change this to 95% grid voltage maximum load. Okay. So change this to maximum load and in the loading category you can change this to maximum load. Okay. So for 95%, we have created 3 cases, 95% grid voltage maximum, minimum and normal load. Next, go to the 100% grid voltage. Again, the same minimum load. So minimum load. And in the loading category, change it to minimum. Okay, click on OK. Now go to this and select copy. And this is maximum load. Click OK and change this description to maximum load. And in the loading category, change it to maximum load. Click on OK. And again, create a copy. This is with normal load. Normal load. Click on OK and normal. Go to the loading here and select the normal. So for 100% grid voltage also, we have 3 cases. 100% grid voltage maximum load, minimum load and normal load. Right? Right. Next for 105% again. So 105% grid voltage, normal load. So here you can see the normal load. And in the loading category, select it to normal. Okay, go to this again and create a copy. 105% grid voltage. This is minimum load. Please select this and in the generation, in the information, this is minimum load and in the loading category, 105% grid voltage minimum load. Okay. Now go to here again and copy 105% grid voltage. This is maximum load. maximum. This is maximum. Okay. So we have created 9 cases total. I have the 9 cases. So 95% grid voltage maximum minimum normal load, 100% grid voltage maximum minimum normal load, 105% grid voltage maximum minimum normal load. Okay. Now if I run these cases, so I need 9 reports and I have to give a proper name for all the 9 cases, right? So I need 9 reports. That's a quite complex. Previously, I have given 95% grid voltage, 100% grid voltage, and 105% grid voltage as a report name. But now 105% grid voltage itself, I have 3 cases: maximum, minimum, and normal load. That means all those 3 files I need to again rename it, right? So, and I have to give, whenever I am running this prompt, so I have to give the report name for all the 9 cases individually. Okay. So is there any shortcut to run these 9 cases at a time? Yes, there is a shortcut that is called the scenario wizard. Okay. So if you need to run, say, such 9 cases, and that's a big project, suppose if it consists of 1,000 buses, and if you are changing, say, example, 3 or 4 parameters of any equipment, again, you need to run all these 9 cases again, and it's a time consuming, right? So for that, there is an option called the scenario. In scenario, you can create what you want to run automatically. So what I'm doing is I'm creating a scenario 1. Let's suppose scenario 1. So for, let's suppose, 95% is grid voltage, and the output report here you can mention it as 95% grid voltage, 95% grid voltage maximum load. Next, create another scenario 95% grid voltage. What is the one? 95%. This is 95% grid voltage minimum load. You can now create another scenario 95% grid voltage normal load. 95% grid voltage normal load. Okay. Similarly, create 100% grid voltage maximum load. Create another scenario 100% grid voltage minimum load. Now create another scenario 100% grid voltage normal load. Okay. Now for 105%, again you have to create 105% maximum load, 105% grid voltage maximum load, and select 105% grid voltage minimum load, and again create a scenario 105% grid voltage normal load, normal load. Okay. Now, so 9 scenarios that you have selected, and if you run the load flow here, so all the 9 cases will be run. So you have the 9 scenarios, right? You have the 9 scenarios. Scenario 1 is 95% grid voltage maximum load. Scenario 2 is 95%. Sorry. 2 is 95% grid voltage minimum. Scenario 3 is 95% grid voltage normal. So maximum load, minimum load, and normal. Similarly, 4, 5, 6, like 9 cases, so we have created 9 scenarios. And if you click OK here, so you will get all the results at a time. Wait 1 second. Probably. Right, this is for the scenario 1. Scenario 2, if you select this and run this, click on OK. Yeah. So here it is creating. So one way is we have to run the scenarios one by one. So go to the scenario wizard here and take the scenario 1, run this. Next, go to the scenario 2. No need to give again the cases and all. So as you already selected this, selected run 2, and go to this scenario 3, run this, go to the scenario 4, run this, go to the scenario 5, run, go to the scenario 6, run, 7, run, 8, run, 9. Okay, so that means you have run the 9 scenarios. So the advantage of the scenario is no need to select this output, means what to say, the case file and the report file. No need to select that. So here you have all this thing will be created automatically. And if you go to the load flow analyzer, so here you have all the 9 cases in a one single shot. Okay. So this is about the study wizard, scenario wizard. Is it clear? Is it clear? Yes.
Yes, sir.
Yeah. Now
Yes.
it is clear. Then just go to the another option that is called the study wizard. There is one more thing that is called the study wizard. So because in the scenario wizard, you have to run each and every scenario individually, right? Because you have to run this scenario, select the scenario and run this scenario manually. So there is another option in this study wizard. So here you can create a new option, that is, let's suppose the macro one, and here you select the option as scenario 1. Similarly, you select the macro 2, scenario 2, macro 3, scenario 3, 4, 5, 6, 7, 8, 9. Okay. Now, if you click on run, all the scenarios, if you see here, all the scenarios are running automatically. And results will be updated automatically. Okay. So you can see all the load flow results have been updated. Okay. So someone has asked me like how to run the load flow cases at a time. So one option is, first you have to create the scenarios, and in the scenarios you have to link the study case and the study case output report. Create different scenarios for each and every study case, and then add those scenarios in this study wizard and create a macro and add all the scenarios which you want to run at a time. And if you click on run, all the scenarios, that means all the case studies will run automatically. Okay. So this is about the study wizard. I hope this is clear.
Yes, sir.
Yes. Yes.
Sir, but
Yes.
how to understand this? The whatever load flow we run, they are means the values are not abnormal. Means things are normal and it doesn't create any problem in future. How to understand
You
that?
can check it in the load flow analyzer. Na? So here you are getting all the things, right? Bus voltages, everything you are getting na, for all the cases. You can export in the Excel and you can check it because you
But
already mentioned, right?
but
For this test
how to,
result.
sir, how to understand that something is abnormal? Because it is showing everything as normal. How to understand that yes,
No,
something is abnormal?
that depends. Like for example, if the bus voltage, if you say for the medium voltage bus, the voltage limit allowed is plus or minus 6%. For the LV bus, that is plus or minus 10%. So if it is within that limits, you can say it's a normal condition. If it is deviating from those limits, you can say that you have to improve the voltage profiles, or you have to put some additional elements to bring back the voltage to within the limits.
Sir, only voltage and current we are going to see, or anything else also?
You can see the power flow also, loads, everything you can see here. That's what I explained you, right?
Okay.
Right. So this is about the scenario wizard and the study wizard, and how to run the reports and everything and all. Okay. So tomorrow probably we will look into the one important topic, that is optimization of the transformer taps, and anything left for the load flow. So tomorrow we will finish that.
Sir, if any corrections have adjusted in this, then all scenarios will run again, or we have to auto?
Yes, we have to run all the scenarios, of course. Suppose if tomorrow the manufacturer or the client will say that no, my impedance is not this one, you change it to 6% and run this load flow. So then if you don't use this scenario and study results, what you have to do, you have to go to the individual case and you have to run it, right? So instead of that, if you go to the study wizard and if you click on run, so all the scenarios will run at a time. Okay, just with a single shot, you can run all the cases.
Okay, sir. Thank you.
Yeah. Yeah,
Sir,
anything else?
when the client is asking to do
Your
the
voice is not
study,
clear. Your voice.
in that case,
Can you repeat again your voice?
sir, when the client is asking, sir, when the client is asking to do the load, means the system study, in that case, the all the like it is, we need to do the load flow, short circuit, relay coordination, then motor starting, everything has to be done, or only load flow or
No,
short circuit will
no, no, no,
solve the
no.
problem?
That depends on the the client requirement. System study means you have to specifically ask the client which studies he wants to perform and what is the requirement, his requirement. So accordingly, depend upon the requirement, the type of studies you have to select.
Okay, sir. And sir, means normally whenever we are going to do this kind of study, load flow, we are going to take this the grid voltage what you considered, na 90%, 98%, 100%, 105%. So all these things we are going to consider. Apart from that, means it varies
Yeah,
case to case
Mr.
also.
Nalini, your voice I am not able to understand actually. Can you means
Sir,
it's buffering?
okay, sir. Sir, now it is okay, sir. Is it audible now?
Yes, now it is audible. You tell me.
Is it really required to do these three studies only? Means grid voltage 95%, 100%, 105%, or apart from that, any other thing has to be considered while doing the load flow?
See, this I have explained the possible scenarios for this particular means this system, right? So if you have some other system, so you have to first find out what are the possible cases, and out of those possible cases, which case will give you the extreme conditions, so that you have to select it. So that vary from system to system. It will not be same for all the systems.
Like when the scenario is like this, like one grid is there and we are taking suppose 132 kV, and then subsequently we are means stepping it down to let's say 6.6 and subsequently to 415. So
Yeah.
in this case, this scenario will be applicable probably.
Yes, yes, yes. If the system is something like this, so whatever I explained, that itself is sufficient.
Okay, but when generation will become, suppose GT is there, then the condition will be different.
Yes, yes, of course.
Right, sir. Thank you.
Yeah. Yes, yeah. Anything else?
Sir, in tools options load flow settings, can you please?
Sorry?
In tools, uh, uh, in tools, there is options, preferences.
Yes,
Yes, sir. Yeah, load flow settings.
yes.
Please explain which normal standard.
See, these things are remaining for this renewable sources. So here the load flow calculation timeout is 60. Okay, that means the default time is calculation timeout for the load flow analysis is seconds. Default value is 60 seconds. That means if your case will not converge within 60 seconds, so the ETAP will mention that the load flow will not get converged. So you can increase this time, but default value is 60. So if you have a big network and if you think like your convergence will take some time, so here you can change that. Next is this is the DC load flow precision for DC short circuit. So here you will get the description also. What is the default precision required for load flow solution? So that means till you get this much of difference, ETAP will try to continuously do the convergence. Similarly, MPPT inverter to maximize inverters and also these are related to the solar flow.
Actually, I am from solar background, sir.
Sorry?
Actually, I am from solar background, sir. So
As of now, in this computer, I don't have that solar diagram with me.
okay.
Yeah.
Okay, sir.
Yes. Yes. Yeah. Any other questions? So if it is okay, then tomorrow we will see one important topic. As I mentioned, we will see how to, means for this same network itself, how to set the transformer OLTC. And if anything left with respect to the load flow, we will cover this and we will complete the load flow tomorrow. Okay.
Sir, I have a doubt. Can you
Yes.
just open this transmission line parameters? There are some parameters which I'm not getting actually. Just open a transmission line. Yeah.
Yes,
Can you
please.
go to the parameters? Yes, sir. This is RT1, we have at 75 degree again. But in my ETAP, sir, it is showing RT1 75 degrees Celsius, RT2 that is at 85 degree. But here it is showing 75. How it is, sir?
Which version of ETAP that you are using this?
2019, sir.
29.
2019, 2019.
Okay, fine. Here you have the option to change this. Go to the impedance here and here you can change this. Okay.
Oh, library, sir. Okay, in impedance I can change it, right?
Yes.
Impedance. Okay, sir. Then, sir, this XA inductive reactance. Gas shunt capacity. One minute, sir. This RT1 positive, negative, 0, sir. But
Yes.
in normally in this conductor data sheet, we only get some in 0.55 ohm for moose. So that will be 0 sequence or positive sequence or
Generally
negative.
positive sequence.
That will be positive sequence. Then for
Positive and negative
negative,
sequence, both are same for the transmission
same.
because it's a static equipment, so it's the same.
And for 0, what I
Zero
will
also you can assume for the transmission, you can assume the same. But for the
Same.
transformer, it's a little bit different. You can assume 90% or 80% of the positive sequence that you can assume.
Okay, for transmission line, I can ensure the same value, no?
Yes.
Okay.
Sir,
T1 or T2. Positive sequence.
Okay. Yeah. Anything else?
And so for XY, also, what value I am getting, only one value, that is for positive sequence or negative?
Yes, of
or
course,
0?
the positive sequence. Yeah, positive.
So I will put positive, negative, 0, everything as the same value.
Yes.
Acha. Okay, sir. Okay.
sir,
Yeah. Right. Mr. Prakash, I'm not able to hear your voice.
sir, please you take one live project to how to proceed, how to
I'm not getting your voice clearly. I'm not getting your voice clearly.
sir. Hello, sir.
Hello. You can type in chat.
Hello, sir. Can you hear?
You can type in chat.
Hello, sir.
You can put your requirement in chat. Yeah, there is one question. Is there any way in ETAP to simulate unbalance? Yes, that can be done in the unbalanced load flow. But what we are doing is the balanced load flow. Okay. Right. Okay, fine. Yeah, if it is clear, so I will end the session and tomorrow we will meet it again and we can perform the, means we will look into the transformer ONTC, how to do the adjustments and all. So with that, we will finish the low flow and probably next week onwards, we will move on to short circuit studies. Okay. Right. Please take one project, how to proceed, means which project that you are expecting, Mr. Prakash?
Any projects, then how to simulate,
So one thing you just give, I am not able to understand. You can give your requirement to Raghav. If we are able to do, so definitely I will look into that. Okay.
Okay.
Yeah. Okay, fine. Right. I am ending the session. So we'll meet again tomorrow at the same time and we will finish the loop for tomorrow. Right. Thank you.